Hi everyone, and this is Building Again, episode 2, and we were going to be discussing about human and machines. In the last episode, in case you missed it, you should watch that. We discussed how neural networks, how large language models like a ChatGPT and stuff, how they learn. And what we mentioned was that they are giving a lot of examples, and those examples are what they learn patterns from. So ideally, they're not smart. They're just paying attention to consistencies in examples, and they're using those consistencies to solve problems, further problems. However, it's not as simple as that, right? It takes a lot of work to get a system to that point. So a very good way to analyze this is to look at how humans and machines think. Now think of it this way. Remember when you were a baby? Oh, you cute little baby. I know that's not you, but you get the idea. Cute little baby. And let's have a robot here. So stick simple. There's a robot. Let's call him Neutrozoid. Okay, that robot looks too fine. Now, how do humans learn? Last week, remember that we talked about a stove, and we said, how does the child know that the stove is hot? Well, there are two ways to teach the child that the stove is hot. You can have a presentation, a slide, and you can have speakers talk about a stove being hot, the effect of touching the stove. Or the child can just learn from experience, where one time they touches the stove and discovers that it is hot. And what happens? The child will never touch the stove again. Why? Because he has felt a burn, he has felt pain, and he understands one thing at that age: stove equals danger. Now, here is the question: what did the baby actually learn from? The baby learned from data. And what is the data? The data here is the baby noticed a few things. Number one, there was a stove. Number two, let me put it here. So let's say we have a raw data. Okay, data number one, there was a stove. Sorry about that. I need to get the pen. Data number two, there was fire. Okay. Data number three, it looked hot. So let's say there was steam. Let's use steam as the heat there. There was steam, it looked hot. So what the baby understands next time is whenever I see these three things, or even if I see one or two of these things, I tend to understand that it would mean bird. That's the outcome. So this is data, this is outcome. Now, how do machines learn? Which is a very good way for us to also analyze this. The machines learn X in the exact same way. Instead of it getting pain as the answer, it actually gets an error signal. More likely you're wrong. Try again. Think of it like this. Let's say we tell the machine 2 plus 2 is 4. 1 plus 1 is 2. Don't say the next thing that came to your mind after you heard that. 3 plus 3 is 6. And then we ask the machine 4 plus 4. You see, the machine might not get this the first time. You know why? Because he does not notice that it is double of one of these numbers that he gets here. 2 times 2, 4. 1 times 2. The machine doesn't know that you add 2. It doesn't know how to do 1, 2, 3, 4. Not yet. It is simply looking for a pattern. And what is the pattern here? The pattern is when you add two numbers that are the same, it sees this addition sign, and you add two numbers that is the same. What you just have to do is multiply this same number by itself. 2 times 2, 4. 1 plus 1, or add the number to itself. Yeah, whatever. Point is, you can easily guess the pattern from human standpoint. And this is what machines do. They look at the examples and they get results. So if we came here and machine said the answer is 9, we will simply tell it your answer is wrong. And it will do what? It will try again and again and again until it gets the final answer, which it is 8. Try and error. That's how machines learn, right? They adjust, they adapt. What is a better way to teach this? So think about it this way. I don't know if you play basketball. I don't. I'm not very good at it. But let's talk about basketball. In basketball, there is a rim and a hoop, right? It's a very fine one. Make it a bit prettier. There you go. The goal is from a certain point, you're supposed to shoot the ball and it would get into this hoop, right? Now, pay attention to this. That's the goal. How about you're not a professional basketball player and we tell you try? Ideally, if I give you a ball and I say shoot and you stand here and you shoot the ball, and when you shot the ball, it just went to the side. It didn't enter. It went here, it bounced off, and bam, bam, you've lost. I think the next thing you do is you'd move up a bit and try from a different position to see if you would still hit. If you went to this position and then you threw it and it went to the other side of the rim, at this point, we assume that you're throwing straight and it goes to the other side of the rim, then that infers something. The distance between this point X and this point Y are the extremes of the rim. Extremes of the rim. Focus. Now, what if we created a point Z, which is the middle of this distance? Stand here. Now, let's take all that away. And we're going to save the data points. Now, remember, we're talking about data here. Data number 1, data number 2. And so we say, okay, if we got data number 1 from X and we got result number 2 from Y, what if we try Z? So we stand here and then we shoot. And if we hit, we have just learned like a machine. Try and error method. We started from X, you didn't get the result you required, you told him you're wrong. You go to Y, you didn't get the result, then you go to Z. Now, a machine doesn't learn that fast. So think about doing this like 1,000,000 or 1,000,000,000 times before you actually understand the perfect position to throw the ball. I'm going to take you to a different level here. You see, every move the machine made was an adjustment. And that adjustment is a feedback. You see, when it was here, it's got feedback that this place is too far, right? And they say, okay, let's adjust. You got another feedback here, and it says too far. And then you adjusted. And you got another feedback here that said this place is perfect. If you're a machine learning expert, you understand that we've just identified gradient descent. And so, don't worry about what that means if you don't understand. We'll get to it in a bit. What have we accomplished? A machine will do this millions of times. It will get results. If the result is wrong, it will adjust. And then it will get a different response until it hits it. Now, what is the difference between a machine and human learning? This is the simple difference here. And that difference is that a baby simply has to see the stove, and I know my drawing is terrible. My sister said so, but that's fine. A baby just has to see the stove, fire, steam, get burnt once, and that is perfect example. They don't need to happen. It doesn't need to happen again. They've learned. However, the machine needs consistent training on many examples over and over again. So you see sometimes where you go online and you say, I need the picture of a dog, or you put up a picture of a dog on Google Images and you say, what is this? And it tells you dog. See, it must have trained on millions of dog data to be able to know dogs properly. And you can even go one step further and say, what type of dog is this? And it says, oh, that dog is a golden retriever, a German shepherd, which means if it had trained on 10 million dogs, we could still have to train it on 2 million German shepherds, 2 million golden retrievers. It sees the images, it knows what they look like, and then it translates results. Now, once again, it's a lot more complicated by this. But when you understand this on base level, you are very, very close to the intuition of how they work and how they are able to generalize easily. So machines need a lot of examples, and humans do not need a lot of examples, maybe one or just a little. You can see the relationship now. Now, this is why we see machines are trained on a lot of data. The more examples they have, the better they generalize. We'll come back to this generalization concept. It's one of the toughest things in AI. But think of it like this. If I tell you that 2 raised to power 1 is 2, and 2 raised to the power of 2 is 2 times 2, which is 4. But I don't show you this here. I don't show this to you. I simply show you this. 2 times 1 is 2, 2 times 2 is 4. You see, I could tell you to do 2 raised to power 3. So look at that example. Like we said, if I give you 2 raised to power 1 and I told you it's 2, 2 raised to power 2 and I told you it's 4, but I didn't show you that 2 times 2 is how I got 4. Or even if I did, this is why your models, your LLM sometimes gives you wrong answers, because it did not have enough examples to work with. I can easily assume that what you are telling me here is that 2 times 1 is what gives me 2, 2 times 2 is what gives me 4, and 2 times 3 is going to be 6. And I will give you that answer confidently, but I'm wrong. This is what we call hallucination in large language models. So when you see, oh, ChatGPT gave me the wrong answer, you see, that's why we say they're not smart. They are simply learning from so many examples, because I did not give you enough examples for you to know that 2 raised to power 3 is actually 8, and 2 raised to power 4 is what? 16. Hence, if I just give you these two as examples, you could get the wrong assumption. So yes, machines learn with lots of examples, and if they don't have a lot of examples, they don't generalize properly. And based off this, we have come to understand something. This is how machines learn. They learn with 4 stages. 1, learning, which happens with a lot of examples. 2, and learning means that they are adding experience, which is all the examples they've seen in the past, plus feedback. And what is feedback here? Are you correct or wrong? If you're correct, proceed. If you're wrong, try again. And if you're wrong, try again means adjustment. So for a machine to learn, it must experience, which is example. It must get feedback, are you wrong or correct? And it must adjust if it was wrong in such cases. So I hope I've been able to convince you and not to confuse you on how machines learn compared to how humans learn. And we've been able to build some intuition here. Next episode, we're going to be talking about data. And I look forward to seeing you. Have a great day.